Hello, hello, hi everyone. So today is day one of our final exam review. So I picked these five questions. Now these five questions aren't, guaranteed to be on the test, or they're not guaranteed to review the whole class. Those are what the videos are for, but it's at least gonna go ahead and hit everything. For this review, I have you can see it. I have our four previous lecture notes. So I'm gonna do my best to try to specifically reference in the video when a material is brought up. So let's go ahead and start. Oh, wait. Before we start real quick, I believe I made a typo I believe. I know I made a typo on this exam. I mean on this review. For this one, it's the limit as x goes to infinity for was it square root of 25x squared plus 3 over x squared plus 1. Okay. All right. So let's wait, is it x squared? No, no, no. It's supposed to be x. Excuse me. Okay. So just a 1. Okay, let's get started. So first, is this function continuous at x equal to 1? If not, label discontinuity. Okay, so funny enough, I had a lot of people make the same mistake for this problem. A lot of you guys, what you ended up doing is you ended up just plugging in x equal to 1 and just saying it's discontinuous or not. I believe I gave you, I did take off points for that because the whole point of this was to show the limit. So I'll probably change the phrasing to using the limit. But let's go ahead and do the limits. So if I'm doing the limit as x goes towards 1 for this function f of x, really because it's piecewise, I have to split this limit into two. I have to approach x from I have to approach 1 from the left side, and I have to approach 1 from the right side. So the left side of x would be right here, so x plus 2, and the right side of x is right there, so x squared plus 1. Then I technically have the luxury just plugging it in. I'll get a 3 here, and I'll get a 2 here. They do not match. Uh, they do not match. Therefore, this limit does not exist, and it is discontinuous. Specifically, it is a whole discontinuity. And this material is a unit 1 material, and it's specifically wait, did I already pass it? I think I did. Yeah, specifically 1.3. Okay, all right. Next, let's go ahead and do the second problem. The second problem is identify the asymptotes for the following. While I'm here, let me go ahead and mark it already. This is unit 1, 1.2. Yes, okay. So first, we know that if this bottom guy reaches 0, and we have this 1 over this power situation, we have to first ask ourselves, what is this power? Is it even or odd? Well, it's even. So that means we have to pay attention to the positive or negative value of this function. It's positive here. So it doesn't matter where this goes, it's going to have this little shape here, the asymptote. So therefore is going towards positive infinity. For here, we have to do some manipulation. So I'm going to go ahead and remember the whole idea of that root power when it's 1 over an x. So I'm going to go ahead and factor out x squared from here and eventually let the x escape in an absolute value. So I have 25 plus 3 over x squared divided by x plus 1. And don't forget you're taking the positive limit. So that's technically can be equally represented just using an x in general. And then you can go ahead and just go ahead and divide out x from everything. So you'll have the upper limit as x goes towards infinity, you'll have the square root on the top, 25 plus 3 over x squared. And then you'll just have 1 plus 1 over x on the bottom. Then you can go ahead and move the limit around. We see that the limit of inside this function would just be 25, so square root of 25, and the limit of this is just going to be 1. And then we could simplify this to be a 5. Alright, next one. This is also a unit 1 question. It says, is the function continuous at x is equal to 2? If it's not, label discontinuity. Again, I should say using the limit or find the limit first. So technically you're finding the limit. X is going to 2 for this function. X squared minus 4 over x minus 2. And you see that if you just plug those in, you'll get 0 over 0. Which, at this point, we technically have learned 2 different ways to do this. We've learned L'Hopital's rule, or we can go ahead and just simplify this expression. For the sake of the problem and reference material, I'm going to simplify the expression because I did put, let me double check. I'm pretty sure I put like a whole section that's like, yeah. So this whole section we're going to use L'Hopital. Okay. So for here, you can either divide the polynomial or you can see that that's different to squares. Let's go ahead and divide the polynomial just for fun. And the inside's supposed to equal this. So we have x squared first. That's going to be an x. And then we know x times negative 2. So is here. So we need to ask us, okay, what times here will give us 0x, because notice there's 0x. What's the opposite of that? Well, just 2x. And then x times what gives me 2, or x times what gives me 2x? Just 2. And then that will just become negative 4. So that does work out. And we can go ahead and factor this to be x minus 2, x plus 2 over x minus 2 cancels out. That's not a whole discontinuity. Oh my gosh, why didn't you say anything? Just kidding. We know it's not that. It's a jump discontinuity. Duh. Sorry. Um, it's not funny. I was gonna make a really dumb joke. I watched this YouTube channel, and then like at one point, two of the YouTubers they say "duh" at the same time, and then they just go into a sing song of like "duh." Like it's not that funny. Told you it wasn't. Oh, I forgot to update the things. Oh my gosh. Let me do that right now. I just realized. Sorry. I was so quick to record. I didn't even think about that. Final review. Yeah, I don't know if you saw that. Well, if you're watching the phone video, you only saw that part up here get updated. And then obviously for you guys watching the vertical video, it's down here and over there. Or over there, mirrored. Okay. So then you can simplify the function like this, and you go ahead and have just x plus 2 for substitution method, and that's just going to be 4 is your limit. And this is a whole discontinuity. You know what? Let me go ahead and just lightly go over that since even I forgot, I guess. Um, Removable or whole discontinuity is when we have the limit of a function not exists, but it doesn't equal to the actual function. Because see, if we plug it in at f of 2, we don't get anything. It does not exist. But here it does. And then we have a jump if both sides exist, but they do not match. And then we have an infinite if we know that the left and the right have these infinities going on. Believe. I think I just don't. Yeah, I was gonna say I don't think it made it its way into the test, so I don't remember giving this kind of question. But maybe it could. We don't know. Okay. All right. Let's move on to the next page. So here's are just some classic limits to evaluate. So let's go. Um, For I haven't decided if I'm gonna make you either evaluate these with or without Hoppitall's rule, but I felt like it was best to just practice both in case I do. Or maybe I give you one limit. I'm like, okay, figure this out algebraically and figure this out with La Hopital. Um, let's start here. Okay, so from here we see that we have this whole radical plus or minus situation. Or first you plug it in, right? Because you need to check if substitution method works. And if you check substitution method, oh wait, oh then there you go. Okay, that's an easy one. You'll have square root of 9 minus 3, minus 9 over x 9 minus 3. You'll get 0, and you'll get 0. You'll get That was probably the typo. This is probably a typo because that seems like it'd be 3 and that seems like it'd be 9 to make sure. We can still we'll do both. Because I don't think I put in like a just a substitution question. I did. Okay. So let's do 3 minus 9 over 9 minus 3. That's gonna be negative 6 over 6. So it's gonna be negative 1. So that would be the limit of this guy. Okay, now let's go ahead and do what I intend this limit to be. Square root of x minus 3 over x minus 9. So for here, you plug it in to be 0 over 0, and you're like, what the heck? What do you do, right? So then you would simplify. By multiplying against this. I hope we remember this, the conjugate. And go ahead and get on the top, we'll get x minus 9, and then we'll get x minus 9 square root of x plus 3. Actually, this is a review. Let me go ahead and actually go over what just happened. So here we see these multiplied and became this x. Here we see these multiplied and became 9. And that's not to say that this guy doesn't multiply to get negative 3 square root of x. And this guy to get positive 3 square root of x. But here you can see that these are opposite chairs, so they will cancel out. Alright, we can simplify top and the bottom by taking out the x minus 9, so we get 1 over square root of x. I don't know why I was going to do a longer one, plus 3. We know square root now as limit as x goes to 9. We know that's going to be 1 over square root of 9 plus 3, and it's going to be 1 over 6. Okay. Alright. Let's keep it moving. Okay. So for here, we have a classic scenario of a top or of a top and heavy, all these sort of function ideas. Let me go ahead and where are we? I believe this is all because limits is like the whole unit, right? Um, but we have, infinites. We have the roots, substitution. Let's say infinity. We have bottom equal and then top heavy. So yeah, maybe for this one, I'm just gonna write unit one, the whole thing. Okay. All right. For here we see that the power of the bottom is greater, so it's going to be bottom heavy. So that means this thing's going to go towards 0. Let me write that bottom heavy. Okay. Then here, if we plug this in, or we see this is going to be top heavy, we can see that that's going to be just going towards infinity. Oh wait, it's not x is equal to, let me go and change the infinity. So there you go. But if we're to do the problem like it's written, sorry, I don't know why I'm making these typos. Okay, x squared minus 5x plus 6 over x minus 3. Plug in 3 for both. I know the bottom will be 0, but the top will be, what's that, 9 minus, uh, it's going to be 15. Oh, plus 6. Yeah, so that's for sure going to be 0 over 0. From there, we can go ahead and divide it out because we see that if 3 is a root between both of these guys, then the the um, the expression x minus 3 should divide both of these guys out. So again, we'll do that x negative 3 puzzle piece, that'll be an x squared, so that's supposed to be an x. If I complete half of this, it would be negative 3x, so negative 3x plus 1 gives me negative 5x, negative 2x. So that'll be a negative 2, and then negative 3 times negative 2 is 6. So that means from here, it can be written as x minus 3 times x minus 2 over x minus 3. Those will cancel out, and you're left with x minus 2, and then you plug in the limit to get the answer of 1. Okay. All right. Let's see. Next one we have here. Okay, so this is balanced because as x goes to infinity, both these powers on top and the bottom are the same. So you take the coefficients next to the highest power, so negative 7 for the top and 4 on the bottom. You obviously can't simplify that, so that's the answer. Okay, pretty straightforward. Um, yes. All right. Let's keep it going. All right, find and classify all the relative extrema of f of x is equal to this polynomial. Then find and classify all the absolute extrema on negative 4 to 4. Okay, so for here, we have a bit of a challenge because, well, first we need to do the derivative. The derivative is going to be 6x squared minus 6x, and then minus 12. Yes. Okay, I'm gonna change colors. But then we see that if we set this equal to 0, we'll have to do a bit more solving. I want to factor out the 6's. So x squared minus x minus 2 is equal to 0. Um, we can quickly solve for this using the AC method to just sort of list things, or yeah, I'd rather just do the AC method. So what is it? Negative 2 times 1, so negative 2. And then what factors of negative 2 add up to negative 1? So we have 1 times 2, 1 times 2, negative, negative. It's going to be this guy. So we have 6, parentheses, x plus 1, close parentheses, parentheses, x minus 2 is equal to 0. Using zero product property, you typically have the technicality of setting all products equal to 0. So 6 is equal to 0, x plus 1 is equal to 0, and x minus 2 is equal to 0. We know this is just nonsense, but it's just part of the process. For here, we know x is equal to negative 1 when x plus 1 is equal to 0, and x is equal to 2 when x minus 2 is equal to 0. So then from here, we have to do the sign chart. What numbers are in between negative 1 and 2? I'm just going to pick an easy one, 0. To the right of 2, 3, and to the left of negative 1, negative 2. And then you can technically do 6, x plus 1, and x minus 2. And you don't have to evaluate. Some of you guys, I noticed on the test, you just evaluated it. It's supposed to be a little bit easier than that, but I consider just evaluating it is so secondhand nature. So you can do that as well. It's not incorrect, as long as you follow the results. For 6, that's a positive number no matter what. For x plus 1, it's going to be negative, positive, positive. And then for x minus 2, it's going to be negative, negative, positive. So the function as a whole would be positive, negative, positive. So it probably means it's a sort of U shape that's occurring. Well, for the derivative, right? But for the original function, that means that x is equal to negative 1 because it goes from positive to negative. That's going to be a relative max. And then from 2, as it goes from negative to positive, that's going to be a relative min. Keep in mind the shape, that's a hill, that's a valley. But then it says find and classify the absolute extrema. So we know while these guys are relative maxes and mins, we also have to check the endpoints, negative 4 and 4 for the original function. So you have f of negative 4, and don't forget we need to check f. I shouldn't write them side by side, but we do need to check f of negative 1, f of 2, and f of 4. 2 times negative 4 to the power of 3 minus 3 times negative 4 squared minus 12 times negative 4. 2 times 64, and then negative 3 times 16, and then positive 48. From here, I can simplify that to 12, 8. Here, that's gonna be, I think that's 48. Yeah, it's 48. 48 plus 48. So the value is 128. Okay. Then we have f of negative 1. 2 times negative 1. Oh, I forgot the negative from here. Excuse me. 3 minus 3 times -1 squared minus 12 times -1. That's going to be 2, -2. This is going to be -3, and that's going to be plus 12. So it's going to be 7. And then for this one, 2 times 2 to the power of 3, -3 times 2 squared, and then -12 times 2. So that's going to be, well, that's just 16 technically. Here we'll have a minus, that's 12. And here we'll have plus 24. So it's going to be 28. And for f is 4, we'll basically have all of this, but that will be positive, and this will be negative. So 128 minus 48, and then minus 48. So both of those 48s equal 96. So 128 minus 96. I think that's just going to be 32. Let me double check. And I was going to double check with all of these, really. T minus 96. Yeah, 32. Okay. Just real quick though, I do want to pop out Desmos just to get the visual aspect. I mean, granted, um, I still haven't decided. Well, here's my logic. If I let you all have a calculator in the test, that gives you guys a lot of technical outs for these problems, so it makes me want to put more questions. If I don't give you a calculator, then technically speaking, if I don't give you a calculator, then excuse me, was it ugly yawn? If I don't put a calculator, then I can give you more or less questions. So that's why I haven't decided. Um, we'll see, I guess, right? Okay. Let me go ahead and keep graphing this. Minus 3x and minus 12x. Okay. So let's see. So this is what it looks like. It's a bit weird. So what I was probably gonna do, just so we can see it better, is I was gonna label it as an f of x function, and then just plug in all of our f's, just to double check our work. Let's start with -4, -68. Okay, oh, wait. Squared. Okay. And then -1, 7. We have a 2, -20. Okay, how did I mess that up? That's interesting. Let's see. That's 16. That's supposed to be -12. That's also supposed to be a negative. So that's where I messed up. So in that case, 16 minus 36. Oh yeah, that's definitely 20. -20. My bad. Okay, I guess it's a good thing we checked. And then 4, 32. Okay. So from here, what's the absolutes? The absolute lowest is at x equal to -4, and the absolute max is at x is equal to 4, -4, +4. So keep that in mind. I gave you points off if you didn't evaluate the endpoints for the previous test. So I'm just letting you know right now. Okay, make sure you include all that. Pretty please. Alright, we have 2 more pages left, I believe. Let's see. Okay. Find the antiderivative of this. Okay, so we know this is just um all of our units 3 and 4, but mainly, let me see. Well, because technically this is everything, right? It's a final review, but I kind of just want to be a bit more specific. This is like unit 3 and unit 4. All right, let's go one by one. Well, this is supposed to be x to the power of -1 over 2. We know secant squared, and I'm gonna rewrite these as well. We got 2x, oh wait, oh, -1, I'll write it like that. And 7x -4. So the answer to this, remember adding 1 to it, is supposed to be x to the power 1 over 2 over 1 over 2. For the exponentials, it's just the same thing. For secant square, we know derivative of that is tangent of x. Let me just double check that derivative real quick. Yeah, okay. And then from here, well, I did the power rule, like notation switch, but technically speaking, like adding ones divided by 0, so we know it's supposed to be ln, so plus 2 times ln of x. Over here, it's supposed to be 7 times x to the power -3 over -3, and then -2x, and then plus c. So this is more or less the answer, but we definitely could fix up the notations. 1/2 square root of x minus 4 plus tangent of x plus 2 ln of x. And then that could definitely be changed up to minus 7 over 3 of x, 1 over x power of 3, minus 2x, and then plus c. And remember, the way to check this is you do a derivative, and if you do a derivative of each of these guys, you should get those values back piece by piece. Okay. Oh wait, that's wrong. It's 1/2, right? But it's in the fraction. So technically, and I saw that only because I did derivative piece by piece. That's supposed to be a 2. So 2 square root of x. Okay. All right, now let's do some derivatives. We have find the first derivative of this. Well, for all of these, and then we're gonna spoiler. We're gonna be doing derivatives for uh this guy as well. Okay, or for these guys as well. Let's go. Um, we know that could be written as x to the power -3. So that means it's -3, 1 over x to the power of 4, because you subtract 1. Now I'm already bringing it down. You'll have 1 over x3 plus 1, and then chain rule means we do this derivative as well, since that's a function within a function. And then we have it times 3x squared. So really, this can be simplified to -3, 1 over x to the 4th, plus 3x squared over x cubed plus 1. Over here, the derivative sign is cosine, and then it's chain rule, so the inside of that, 2x. Negative, or -3, derivative of cosine is sine, but negative, of 2x, and then derivative of that, 2. So from here, this could definitely use some polishing. We have 2x cosine of x squared, and then that's going to be a positive 6 sine of 2x. Next, we have derivative of this. So we know for exponentials, it stays the same. But then we have to multiply the derivative of what's inside it, which is technically going to be another chain rule. So it's going to be cosine of x squared, and the derivative inside that is just 2x. So put these all together, 2x cosine of x squared, exponential sine x squared. And then this guy is product rule. So let me go ahead and just quickly do the notation for that. F of x is equal to e to the x. F prime of x is e to the x. G of x is x. G prime of x is 1. So we have first f prime times g minus f times g prime, and then over the bottom squared, so x squared. Um, a quick example that I want to do, because I know I saw it on like at least two of you guys. You guys did this. You guys just rewrote it as ex and then times x to the negative 1, which is valid. Like that's not wrong in the slightest. Um, you can go ahead and do that, no problem. If you do first the derivative there, ex, x negative 1, and yeah. And then if you do the derivative of the second one, you'll get negative x to the power of negative 2, and you'll get ex. Oh wait, well, I'll put divide by 1 for now, because then what you should do is, okay, if I put all these products on the bottom by multiplying both the top and the bottom by x squared, you'll get a leftover x next to the first one here. All of those x's would cancel out, and then on the bottom is just x squared, which is the exact same thing. But I don't believe I gave you points off for that. If I did, let me know. I'll give you those points back for sure. Okay. Um, right. Last page. So now it's going to be evaluate using the L'Hopital's rule. At the top here, we see that that's going to be 0 over 0. So we can definitely do derivative to get that. So derivative of top is 1 over 2, 1 over square root of x, and then divide by 1. Yeah. Oh, okay, sweet. So I don't know why I had a brain fart there. Because that's going to be 0 and that's going to be 0, so yeah. Um, just rewrite, excuse me, just rewrite it. We know we plug that in. We get 1 over 4, so the answer is 1 over 8. Okay. All right. Next one over here. Technically, we can just use the fact that it's a balance, and we know the answer is negative 1. But let's go ahead and do the derivative since both of these will go towards an infinity. We'll have 4 minus 2x over negative 3 plus 2x. They also go towards infinity again, so we can do the derivative again. We'll get negative 2 over 2, and that's negative 1. Over here, we see that well, this one we should double check if we get 0, because it's not going to be infinity, so 4 minus 2 minus 2. Yeah, so 0, and then that's 0. 0 over 0. So we can do a derivative here. That's going to be 2x minus 1 over 1. And we can just plug that in. We got 2 times 2 minus 1. That's going to be 3. All right. Let's see. Okay. Then from here, we see that this is going to be another situation where it's the same bounds. Well, let's do a derivative. We got negative 18x over 1 minus 4x. And then that canceled out. And then same thing with the infinities. Do one more derivative. Negative 18 over negative 4. That can get simplified to a positive 9 over 2. Which, funny enough, is that same thing over here. But we would have done the extra step and just cancel out the negatives. Okay. So that wraps up everything, guys. I will be available over, Canvas for any questions. But yeah, just reach out, pretty please, if you guys need anything or have any questions. All right. I wish you the best. There's going to be a part 2. We're going to do another review tomorrow, and then then the final will start Wednesdays. Please keep that in mind. All right. Enjoy the rest of your day. Make sure you're studying, please. Bye bye.